Okay, welcome back once again uh, for class 12 chapter alcohol, phenol, ether, and the subtopic is physical physical property of alcohol. Physical property of okay ether. So physical property of ether we will continue. Now we can see the C single bond O in ethers are polar and thus ethers have a net dipole moment. This weak polarity of ether do not appreciably affect their boiling points, which are comparable to those of alkanes of the comparable nuclear masses, but are much lower than the boiling point of alcohol as shown in following cases. Okay, the formula is CH3 into CH2 whole cube into CH3. We will take it N pentane and boiling point Kelvin. Okay, ethoxyethane C2H5 single bond O single bond H2H5 C2H5. Again butanol CH3 bracket CH2 cube whole cube and OH. Now the large difference in boiling point of alcohols and ether is due to the presence of hydrogen bonding in alcohols. This miscibility of ether with water resembles those of alcohols of the same molecular mass. Both ethoxyethane and butanol are miscible The miscibility of the ether with water resembles those of alcohol of the same molecular mass. Both ethoxyethane and butanol are miscible to the almost the same extent, 7.5 and 9 g per 100 ml water, respectively. Okay, while pentane is essentially immiscible with water. Can you explain this observation? This is due to the fact that just like alcohols, oxygen of ether can also form hydrogen bonds with water molecules as shown. Is it? So are sharing with now chemical reaction. Cleavage of C single bond O in ethers. Ethers are the least reactive of the functional group. The cleavage of the CO bond in ether takes place under drastic conditions with excess of hydrogen halides. The reaction of the dialkyl ether gives two alkyl halide molecule. Okay, ROR plus HX. RX plus H plus R OH sorry, such that this will also. Alkyl aryl ethers are cleaved at the aryl oxygen bond due to the more stable aryl oxygen bond. The reaction yields phenol and alkyl halide. Okay, now we can see Ethers with two different alkyl groups are also cleaved in the same manner. Is it? So R single bond R dash plus HX, so RX R single bond X plus R dash OX. The order of the reactivity of the hydrogen halide is as follows: Hi greater than Br, HBr greater than HCl. The cleavage of the ether takes place with the concentrated Si or Br at a high temperature. Okay, we can see, however, when one of the alkyl group is a tertiary group, the halide formed is a tertiary halide. Okay, CH3, CH3, CH3O, CH3 plus HI. Okay, now we can see it is because in step 2 of the reaction, see step 2, the departure of the cleaving group HO single bond CH3 creates a more stable carbocation CH3 whole cube in C plus charge, and the reaction followed SN1 mechanism. We can see in case of anisole methyl phenyl oxonium ions C2H5OH plus CH3 each formed protonation of ether. The bond between O single bond CH3 is weaker than the bond between OC6H5 because the carbon of the phenyl group is sp2 hybridized and there is a partial double end character. Next one is, therefore the attack by I minus ion breaks OCH3 bond to form CH3I phenol. Do not react further, give halide because the sp2 hybridized carbon of phenol cannot undergo nucleophilic substitution reaction needed to conversion of the halide. Thank you for watching.